GATE ECE 2025. The intrinsic carrier concentration of a semiconductor is 2.5 into 10 to the power 16 carriers per meter cube at 300 Kelvin, nothing but room temperature. If the electron and hole mobilities are 0.15 meter square per voltage second and 0.05 meter square per voltage second respectively, calculate intrinsic resistivity of the semiconductor. Here one more parameter is given, charge of an electron, which is 1.6 into 10 to the power minus 19 coulomb. In the question, we need to ask intrinsic resistivity. Now, let us start with the conductivity of a semiconductor. If we consider a semiconductor material, the conductivity of a semiconductor depends on two kinds of charge carrier. Here, electrons which are flowing in a semiconductor material towards positive terminal of the battery and holes which are positively charged moving towards negative terminal of the battery. So negatively charged electrons and positively charged holes are the two charge carriers contributing for conduction in a semiconductor material. Writing the same in the form of mathematical formula, conductivity sigma equals Q times, Q is nothing but charge of electron multiplied by number of electrons N multiplied by mobility of electrons and number of holes P multiplied by mobility of holes mu P, and the unit is Siemens per meter. Now in the given question they asked us resistivity. So resistivity is nothing but reciprocal of conductivity. So resistivity rho equals 1 by sigma. Here they also ask for resistivity of an intrinsic semiconductor. Intrinsic semiconductor, we are writing it as rho I. So here we are going to calculate 1 by sigma. At the same time, we need to consider pure semiconductor material. In a pure semiconductor material or intrinsic semiconductor material, number of electrons N and number of holes P are equal in number. So taking this N and P common, it becomes Ni, intrinsic carrier concentration, which is given in the question. And rest of the things are inside the bracket, mobility of N and mobility of holes. And the unit of resistivity is ohm meter. Now, let us substitute the given values in the question into this formula. Here it is resistivity of intrinsic semiconductor 1 divided by charge of electron 1.6 into 10 to the power minus 19. Intrinsic carrier concentration 2.5 into 10 to the power 16 carriers per meter cube, and mobility of electron 0.15 meter square per voltage second, and mobility of holes 0.05 meter square per voltage second. Now if we can try to simplify this 10 to the power minus 19, here it is 10 to the power 16, the whole thing simplified to 10 power minus 3. And inside the bracket we have 0.15 and 0.05, adding the two we get 0.2. This 10 power minus 3, if we take it to the numerator, it will become 10 power 3, and the rest of the terms 1.6, 2.5 and 0.2 gets multiplied. We get the value of 0.8. 1 by 0.8 will give you 1.25. This 10 to the power 3 becomes kilo. So 1.25 kilo ohm meter is the value of intrinsic resistivity. Now if we check with the given set of options, option B matches with this.